Welcome to another iFull Diary entry. I am in the VM. I'm trying to implement the runtime currently, and I am currently implementing charge gas. Now the interface that I had originally defined in actors was, so these used to be numbers, just number and number, and I have to be careful around what types in JS types I assign to the various Go types. In JS we have number and begint essentially for integers, and so number has a max safe value, and basically you have to be careful when converting between the various Go int types to the JS int types. So I made a little helper note here. So if it's an int 8, then it can fit in a number. Int 16 can fit in a number. Int 32 can fit in a number. Int 64 cannot fit in a number, unfortunately. So it has to be a big int. Obviously, also I should really put down here, so a big.int, that has to be a big int as well, but this one has the special CBOR encoding. So it doesn't map. Oh, Cobra. So it doesn't map to a just a number type in CBOR. It is just encoded as a uint8 array, big endian. So that's kind of fun. There we go. So I just need to make sure. What happened here? Begin. Cool. Stop correcting it. That's great. And so I found this this website really useful for this, because it just listed out the numbers in big long form, and then I was just able to so I can see number dot max safe integer. I don't know if you can see that, but that's like 9 something huge, 9 quadrillion or something. Yeah, but still you can see quite easily that for int 64, that value is significantly less than that. All these other ones it fits in, that's fine for ints, and also for uints, unsigned integers. Obviously uint 64 doesn't fit. So that's the number mapping we're going with. I'm sort of trying to keep to, well, I could use big ints everywhere, I guess, but they are just a tiny bit more awkward to work with, because if you want to put a big int literal, you have to either put an n, the letter n, after the number to tell a compiler that's a big int, or wrap it in a big int constructor function call, which is fine, but it's just a little bit extra boilerplate. So I'm trying to keep to number where possible, and and big int only when necessary. Okay, so that's that. So yeah, I had to change these to big ints because they were actually defined as int 64s, and then I'd already implemented. This is Lotus. That's why. Here we go. I'd already implemented this gas charge class, and I'd already used big ints here and stuff. So it needs to be the same. Also, there's problems. There could be problems of consensus if we use number types that can't store high values, or do like multiplications and additions and things with them properly and get the right answers. If we don't come to the same conclusion, then things are bad and forks happen. So we want stuff to be right. So anyway, charge gas. So I've just got to here. This enable gas tracing seems to be some sort of global in Lotus. Yeah, that's why I was at the top here. I'm just gonna because we can't have kind of globals in ES modules. I'm just going to create a setter function to set the value. Okay, let's just turn that off. Okay, so set gas or set gas tracing enabled. That's fine. Whatever. Value, I guess. I don't know. Value. Just turning, I don't know if I explained this, but I turn most of the Go comments into these types of long form comments just because the tooling will give me like nice helpful text if you put it in long form, whereas if you just have a regular comment, then you get nothing, which is helpful for the developer, I guess, but not helpful. Yeah, see, nothing. So that's no good. So we make it long where possible. And unlike Go, we don't have to type the name of the variable in the comment. Okay, so set gas tracing enabled. Yeah, okay, great. So if I think I should probably let's call it this because that makes a bit more sense. I think gas tracing enabled. Set gas tracing enabled. Yeah, perfect. If gas tracing is enabled, I don't know what this coolers is. Interesting. Runtime coolers. Okay, so this this skip variable came from. If we look at Lotus, where are we? We've got so this charge gas is like, so this is the runtime interface function. There's a private charge gas. There's a function called charge gas function, which returns a function that calls a charge gas internal, and there's this charge gas internal function, which is called by the interface function and this charge gas function. So yeah, I'm not really sure why there's so many. Anyway, so I think we can't really skip so this is about, I think, skipping like stack lines or something. Build the clock now. Okay, this time. What is time? Time is yeah. Good. Wall time second. The wall time seconds, the wall time nanoseconds. And optional monotonic clock reading in nanoseconds. I'm wondering if We could maybe just use date.now for this information. Although we've got this like time taken. So we need some sort of, ideally we need some sort of high resolution time. I'm gonna have to do some Googling, I apologize. So high resolution time, yeah, okay, hang on. Hi. There we go. Milliseconds are the best you can hope for in JavaScript, and like I said, isn't very accurate. High resolution time. It's called high resolution time. Sub-millisecond accurate time span by calling reload.performance.now. Okay, so I assume that I can okay. Oh no, I can't read the spec. Come on. So maybe I can search for MDN. That's the one I want. I've been here before. Tom Iris timestamp. Okay, that's great. Okay. Oh, okay. Since the time origin, yeah, this is the interesting thing. Since the time origin, I guess it doesn't matter. Does it not matter? Because I'm looking for time taken. Fast gas. Okay. Cool. All right. So. So now I guess will be performance.now. Yep. That's great. Ask us charge if yeah, right. This is a private one, it's not null. Then this dot last gas charge dot time taken equals, what have I put this as? This is a big int, but it's not, this is just a number. Is it going to take 9 bajillion? I think these charges are not, these traces are not saved to chain, so I think it doesn't matter. Yes, and look, I've even defined them without with strings. Yeah, I've even defined them without encode cbore and decode cbore because I don't think they are. Yeah, I think. Okay. I'm gonna maybe change this to a number for now. So these, I think these have to be big ints because they are in the actual gas thinger, gas charge. These are actually big ints here. So okay, let's do window.performance of now minus now. I guess I should probably leave off this. Yeah, because in Node it'll be window. Sorry, it'll be global. Hopefully there's a performance done now in Node. Let's have a look. Oh, hold on. Global. No. Okay. Maybe I need a module. Okay, well let's, I'm guessing behind the scenes this uses Node's HR time. Hang on. Both with paramount for this only uses it as. Okay, browser process HR time. Guma is interesting. Okay. Doesn't provide the same level of time precision as node.js, but provides a matching API and response format. Okay. But okay, does it use how does it work? Okay, so it uses performance. Okay, great. And this is like A4 1 bytes, so I'm not feeling too worried about including this. Okay, great. Okay, how am I meant to use this? That's it. Performance. And then okay. Yeah, I guess this works. So performance. So I'm going to add a performance here. Okay, so then when this is constructed, yeah, it should be fine. Hopefully. This.performance.now. Great. Okay, so this should work in Node and browsers. Time taken was okay. Now let's subtract. Wait a minute. What? Last gas charge time. Okay. Number. Yeah, okay, that's great. Okay, what's wrong? Oh, it could be undefined. Charge. We need to check. So this will exist. Ah, TypeScript. Okay, that's it. Okay, so I don't know about this. I'm just going to comment this out for now. So gas trace is going to be new gas trace name. Okay, so name location. Yeah. Don't know how this location comes into being. Got no location, so total gas is to use. Compute gas is gas.compute gas. Oh, okay. Sorry. Storage gas. Then virtual compute gas is gassed up. Virtual compute. And then virtual storage gas is gassed up. Virtual storage. Time taken. Oh. Yeah, we don't know that yet, do we? So. I think we're never gonna know that right now, are we? Yeah, I don't know what this callers is. I don't know what line numbers. Let's have a look. Fills the slice program counter with the return program counters of function invocations in the calling go routine stack. So I guess this is for getting a stack trace. But this gas trace, we've got lines, a location. Didn't seem to be used. Oh, okay. So this is when it becomes JSON. It refers to callers. Okay. I wonder if there's something that I can get a stack trace. This whole stack tracing seems a bit, it's not going to be used in production, is it? It's probably super useful for debugging. Okay, but first of all, it looks like in the gas trace constructor, we're never going to know location. It's never going to be. Yeah, it's going to be nothing. Time taken is always going to be don't know. It's not known at construction time, so let's make this optional. So what to do with the stack? have a look. Call sites. Kind of, I think I don't really want. This would make this really node specific. Yeah. JavaScript. Yeah, so this is what I was thinking of doing, just getting the stack. It's probably... So how does the... So this has like array of call site objects. What is error.prepare stack trace? Let's have a look at that. I don't know. Should have clicked on that. So if I do... Yeah, because this is a... Okay, so what's this doing? Oh! Okay, hang on. No. Oh, it's error.prepare stack trace. Okay. Yes, this is a V8 thing. Okay. I'm guessing. Let's just double check. Okay. What? Does this still work? Maybe it's a node thing. Or maybe it's something that's called when stack 0 dot. Yeah, okay. Hang on. Let's just double check this in Chrome. Stack. Ah, look, you're an array. You're an array. Okay, and the other one is a string. Okay, so this would not work. So this will work in Node, but not in the browser. So what I guess I could do is I could have a. I wonder. I guess we could parse the error stacks in some way else. Node and browsers. Well, that's good. Yeah, I mean, this looks complicated, but it's used by lots of people. Stack Tracy passes stacks from an array object. Items, each item. Cool. Okay, so let's try this. Ah. Stack Tracy. Okay, Stack Tracy. Stack or from raw string. Okay, so I guess what I can do, I'm not going to use these callers, but I will add a. So equals new Stack Tracy, and then location equals stack dot, what was it? Items Okay, we're going to skip the first one, I guess, because that's where this came from. Stack.items.slice one.map. And then what are we looking for? So what have we got in here? Line and column and file name, is that what we wanted? File, line. Function. Calling? Okay. File line calling. Okay. And location is just a Is that okay? No? The property line are incompatible. Okay. Right. Why would line? Okay. Sure. Okay, let's just call this a for location. File. Line is line or function is load.callie. There we go. And then we have a location that we always assign to, so that's great. So this is always a string. Oh, great. Okay. -1. I mean, I don't like that, but maybe. When would it be undefined? How would? Yes, because if it's 0, I don't want to turn it into a -1. Okay. Great. So this has been fun. Oh, great. Okay, so no callers. That's fine. We just get rid of that entirely. And we've got extra. Location is created. So this is done in just 2 JSON in Go, probably for performance reasons. Yeah, I think just have to live with that for now. If it becomes a problem, then we'll figure something out. So this will all be wrong now. We don't have that. We won't have that. I think now, is that it? I think that's it. Name to use compute gas, storage gas. Yep. Okay, right. So that's the gas trace. Gas trace. Virtual guest or virtual compute. What happens here? I guess 0 and okay, right. So if gas trace of virtual stuff. Oh, okay. What? Oh, okay. 0n. Okay. Virtual compute gas. Compute gas. Yep. Total virtual gas, do we? Total virtual gas. Oh, okay, so we already do that there, but okay. Well, I think we should probably default them when we create it, right? Gas.virtual storage, or it's going to be gas.storage gas. Okay, that's those two lines. If it's not 0, then use that. Otherwise, yeah. Okay, great. And then the total, we don't need to work out the total because it's already done in the constructor. This is extra. We didn't have any of that, so that's fine. So this dot execution trace dot gas charges equals dot push. Because this is just an array, I guess. Yeah. Okay, so this dot last gas charge time is now, and this dot last gas charge is this trace. Rad. Okay. Oh man. Okay. Okay. So we figured out the cooler thing. Oh right. Okay, that was lots harder than it should have been. Overflow safe. Okay. Sure. That's great. So this dot gas, if this dot gas use is more than this dot gas available minus to use. Gas use. Okay, const gas use equals this dot gas use. This dot gas use equals this dot gas available. Okay. And then a bad happened. Okay. Okay. Exit code is going to be exit code dot sys out of gas. This will be hang on. This is just a message, so I need to use format for this. Oops. Gas available. Let's just format this a little bit better. Okay, cool. And then plus equal to use, so we throw here or add it. Oh. Okay, and that is charge gas implemented. Hooray! Great. All right. Thanks for watching.